Hello everyone, this is Professor Robert Solis. Welcome to this video lesson. We're going to continue talking about the twos complement. Specifically, I thought, let's go ahead and deal with larger negative numbers to see how to handle that, but let me just remind you what the twos complement looks like. You'll see over here that I have 9 minus 4, and so I'm taking that 9, I'm converting that to binary 1, 0, 0, 1. That's pretty obvious, right? That's the 1's position, 2, 4, 8 position. And then I have the 4, so I'm going to convert that to binary. So that's 0, that's 1, 2, and 4. Now I include the prefix 0 there because I'm dealing with a 4-digit number up here, so I got to include that prefix 0. So really it's 1001 minus 0100. All right, so what I'm going to do is I'm going to take that negative number and convert it into the 1's complement. The 1's complement is nothing more than the flipping of the bits. So every 0 becomes a 1, every 1 becomes a 0. So 0, 1, 0, 0 becomes 1, 0, 1, 1. We call this the 1's complement. The 2's complement is the addition of 1 to a 1's complement. So here's the 1's complement of the number we are investigating. I add 1 to get the 2's complement. So 1 plus 1, that's 1, 0. So I put the 1 over here, I put the 0 over here. 1 plus 1, that's 1, 0. I put the 1 over here in the carry, I put down the 0. 1 plus 0 is 1, and then 1 by itself, that's 1. So the 2's complement of 0, 1, 0, 0 is 1, 1, 0, 0. Okay, so now that I have this, let's take our original number, which is 9. And so now I take that 9 and I add it to the 2's complement. So see, that's how you work with negative numbers in binary. You convert the negative number into its 2's complement and then you add it. So then when I take that 2's complement number, okay, so 1 plus 0, that's 1. 0 plus 0, that's 0. 0 plus 1 is 1. 1 plus 1 is 1, 0, so I take the carry, put that 1 over there and put the 0. Now, in terms of a carry, you ignore the carry. Since I know that the positive number is the larger number, if I ignore the carry, notice what I get. 9 minus 4 is 5. 1, 2, 4, 8. So the 1 is active, the 4 is active. 4 plus 1, that's what gives me the 5. Okay. So that is the 2's complement with a pretty simple problem, namely a larger positive and a smaller negative number. But now let's consider another example. What if the negative number is the larger number? How would you handle that? Okay, so first of all, if I take 9 and convert that to binary, that's 1, 2, 4, 8. 8 plus 1 is 9, so that's the binary representation of 9. This is the binary representation of 12 because that's 1, 2, 4, 8. 8 plus 4 is 12. So this is the same thing in binary, or I could put a little tiny number 2 here, a little tiny number 2 here to show you that that's the base 2 of this base 10 number. Basically, we're subtracting this from this, but in binary, you are learning that you take a negative number and you convert it to its 2's complement. Let's start off with the 1's complement. We flip the bits. 1 becomes a 0, 1 becomes a 0, 0 becomes a 1, 0 becomes a 1. Now that I have the 1's complement, you are now going to add 1 to obtain the 2's complement. 1 plus 1 is 1, 0, so I put the 1 over here for the carry and put the 0. 1 plus 1 is 1, 0. Here's the 1 for the carry, put down 0. 1 plus 0 is 1, and then of course the 0 just simply works its way down. So this is the 2's complement of 12, negative 12 specifically. Now the question is, what is 9 minus 12? So I'll take that 9, which is over here, and instead of subtracting, I add the 2's complement. So when I add the 2's complement, which I just formulated over here, 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1. All right, now with this number, I'm going to, now I shouldn't have written this down, sorry about that, ignore that. We're going to take that 1's complement and I'm going to convert it back to its 2's complement. So I take this, flip the bits, 1 becomes a 0, 1 becomes a 0, 0 becomes a 1, 1 becomes a 0. I add 1 to this, so 1 plus 0 is 1, and of course that's going to be 1, 0, and 0. So what is this? Well, that's the same thing as 1 plus 2, which is 3. Since the larger number was the negative, I'll go ahead and put the negative in front of there. So that's how you work with a number that's negative, a larger negative number. You just simply have to understand we're doing the 2's complement once, and then you perform the 2's complement again after the addition, and that's the actual number. So this is actually what happens in your CPU when you're dealing with the subtraction of numbers. It's really the addition of the 2's complement. And then if the number really ends up being negative, one of the flags that is available in a CPU is the sign flag. So the sign flag is either going to be on, indicating that there is a sign, namely negative, or it's going to be off, indicating that there is no sign, namely positive. So the sign flag right here is going to be activated because the larger of the two numbers is negative, so the sign flag is going to be on with whatever the result is that we've obtained. Okay? And that's it. So this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.